Hi everyone, Dr. Mike here. In this video we're taking a look at the hypothalamic pituitary axis and all the various hormones produced. Let's take a look. Now to begin, you can see I've drawn this image up here. It is not what you think, unless you think it's the hypothalamus and pituitary gland, then in that case it is what you think. We are looking at an area of the brain highlighted here in red. So I've taken the brain, we're looking at it from a side-on lateral view. We've sliced it down the middle. Now, is that a sagittal view? Is that a coronal view? Different topic, but it's a mid-sagittal view, taking a look in, and there you can see deep and inferior to the brain, we've got the hypothalamus and the pituitary gland. So let's just label it up here. We've got the hypothalamus up here. Now, hypothalamus means below the thalamus. So here we've got the thalamus. The thalamus is the relay center of the brain. Any sensory information that comes up from, obviously, your sensory receptors that you need to be conscious about or aware, it must go through the thalamus. That's an aside point. So we've got the hypothalamus here, and below we've got the pituitary gland. Now sometimes the pituitary is also referred to as the hypophysis. The hypophysis. So hypo again meaning below, and physis means growth. It's the below growth. Now, if we have a look, you can see there's two lobes of the pituitary gland. On this side, we've got what's called the anterior lobe of the pituitary gland, and on this side, we've got the posterior lobe of the pituitary gland. Here we've got a stalk called the infundibulum. Isn't that a great name? Infundibulum. Infundibulum. And what we have is the hypothalamus communicates to the pituitary gland, anterior and posterior, to tell them to release hormones. The hypothalamus is known as the master regulator of the endocrine system. And if we think about why that's the case, it's because it either releases hormones or stimulates the pituitary gland to release the hormones that can travel through the bloodstream to the body. If we take a look here, what we've got is, I said that the pituitary gland can also be called the hypophysis. The posterior pituitary can also be called the neurohypophysis. Neurohypophysis. And the anterior is sometimes called the adenohypophysis. Adenohypophysis. So we know hypophysis means undergrowth. Adeno means gland, all right, the gland undergrowth. And neuro means nervous, right, nervous tissue, neural tissue. Why is that? Let's take a look. How does the hypothalamus communicate firstly with the posterior pituitary? The hypothalamus will have neurons in particular nuclei, and these neurons will project to the posterior pituitary. So here we've got these neurons projecting down to the posterior pituitary. If we have a look at the anterior, the hypothalamus again has neurons, because it's nervous tissue, that will project into an area called the median eminence. So that's called the median eminence. Median eminence. And here at the median eminence, these neurons are going to communicate with a blood supply. And this blood supply will travel down to the anterior pituitary. This blood supply is called the hypophyseal portal system. Hypophyseal portal system, sometimes called portal vein. Let's call it portal system. And then it communicates to the anterior lobe of the pituitary. See the difference? Posterior is all nervous tissue, and anterior has nervous to a blood supply, and then where does it go to here? To more tissue. So we're going to have cells here which makes up endocrine tissue because these cells produce and release their own hormones. Hence, adeno, it's a gland. Both of these will release hormones into the blood supply of the body. So let's just have that just indicating it's been released into the bloodstream of the body. There we go. So both of these result in that. All right, now we can have a look. The posterior pituitary is called the neurohypophysis, not just because of those neurons, but because embryologically, the posterior pituitary is an extension of the hypothalamus. It's an extension of the brain, of nervous tissue. But the anterior pituitary is not. It originated from elsewhere in the body and snapped on to this particular area. And that's why it's called the adenohypophysis. It's important to know this because their regulation is obviously going to be different. Let's first start with the posterior pituitary. The posterior pituitary has two major hormones that it releases. Now these hormones are going to be produced at the hypothalamus, travel down these axons and get released into the bloodstream to go to the body. And these hormones include what's called anti-diuretic, if I learned how to spell properly, anti-diuretic hormone, sometimes termed ADH. Sometimes in the US it's called vasopressin or arginine vasopressin, but I'm not in the United States, I'm in Australia. And the other hormone that it releases is oxytocin, which you've probably heard colloquially as the love hormone. Again, these hormones are produced in the hypothalamus and are sent down these neurons when the hypothalamus is stimulated to tell them to release them into the bloodstream, and that's how we get them released. What do these hormones do? So antidiuretic hormone, anti means opposing, diuretic, diuresis, means to lose water, right? So lose water or to pee. So it's an anti-pee hormone. So it travels to the kidneys. Travels to the kidneys, specifically it travels to the nephron or the nephrons of the kidneys. So they're the tubes. So if we were to draw up a nephron, right? There's a little Pac-Man head, there's the proximal convoluted tubule, there's the descending limb, ascending limb, distal convoluted tubule, and then you've got the collecting ducts. So we're going to have antidiuretic hormone putting in little holes in the distal convoluted tubule and the collecting ducts. And these little holes are called aquaporins, and they allow for us to pull water from the nephron back into the body. So it allows for us to reabsorb water, meaning whatever comes out here comes out as pee, right? But if we're pulling that water back, well, it's the anti-pee hormone. We're taking water out of what will ultimately become our urine. When would this get released? In times of dehydration. So think about it. If this is your body, this bucket, and you've got a certain amount of fluid in your body, and you've got a certain amount of things dissolved in that bucket, but you dehydrate, so you lose water, you don't lose those solutes, the things dissolved in it, but you lose the water, but you've got the same number of solutes, but it becomes more concentrated. So this increased concentration or increased osmolarity or osmolality, that's another conversation, that increased basically concentration surrounding your cells, that's what stimulates the hypothalamus to trigger the release of antidiuretic hormone. What about oxytocin? Oxytocin tells smooth muscle to contract. So it tells smooth muscle to contract. Now, the smooth muscle it's specifically referring to here is the uterus and the muscles of the lining the ducts of the mammary tissue. So this helps in labour, so helping get bub out, and this helps for milk ejection. So this oxytocin, how does that get stimulated? All right, think about this. A mother is giving birth. As the baby's head moves through the birthing canal, its head stretches the cervix. That cervical stretch stimulates the hypothalamus to release oxytocin. Oxytocin gets released and tells the uterus, which is behind the cervix, to contract, which helps push bub out. As bub continues to push, it continues to stretch the cervix, continuing to stimulate the hypothalamus to release more oxytocin, contracting the uterus more, and you've got a positive feedback mechanism until bub is pushed out. With the milk ejection, it stimulates the tissues to contract, the mammary tissue, to squirt the milk out, and that's milk ejection. Now, you might have heard of it as being called the love hormone. It does play a role in solidifying relationships, both positive and negative. So that is the posterior pituitary. They're the two hormones. Now, anterior gets a little bit more tricky because the hypothalamus is going to produce and release hormones that it drops into this hypophyseal portal system, and then these hormones must stimulate this gland to release more hormones. So unlike the posterior where we've got one set of hormones that gets produced and then released, we've got one set produced, released, and then another set produced and released. Let's take a look at those. So firstly, let's have a look at the hypothalamic hormones. So let's take a look. First, now this is in no particular order. The first one is going to be what's called gonadotropin, and I'm just going to write RH for releasing hormone. Gonadotropin releasing hormone. You might sometimes see it written as G lowercase n RH. The next is going to be, I'll do it in a different colour, growth hormone releasing hormone, sometimes written as GHRH. Another one is going to be corticotropin releasing hormone, sometimes written as CRH. I wrote that as 2, but that's number 3. And then number 4, we've got thyrotropin releasing hormone, sometimes written as TRH. Now, there's actually other hormones produced here. These are the stimulatory ones. So I can actually write a little plus sign next to all these because they're stimulatory. But there are inhibitory ones. For example, the two inhibitory ones that you should know are going to be growth hormone inhibitory factor, or inhibitory hormone, and then the other one is prolactin inhibitory factor. Now they've actually got additional names. So the growth hormone inhibitory hormone is also known as somatostatin, and prolactin inhibitory factor is also known as dopamine. And these are inhibitory. Growth hormone inhibitory hormone obviously inhibits growth hormone, and prolactin inhibitory factor obviously inhibits, not dopamine, but prolactin, which is going to be talking about here. All right, so we've got 1, 2, 3, 4, and then these ones here. Let's look at these. Firstly, gonadotropin releasing hormone. If you see, can you see gonadotropin, corticotropin, thyrotropin? This suffix tropin means it's a hormone that's going to another gland to tell it to release another hormone. Which one doesn't? You've got growth hormone releasing hormone, right? That's just going to go tell growth hormone to be released. But gonadotropin releasing hormone is going to go down here to tell the gonadotropins to be released, which go to another gland to tell more hormones to be released. That's what the tropin refers to. So let's start with one. The gonadotropins are released, produced and released by the hypothalamus, travel down these axons to the median eminence, and then they jump into the hypophyseal portal system where they travel down, and then these gonadotropins stimulate at this endocrine tissue here in the anterior pituitary to release the gonadotropins. So let's write this up. Let's draw a line here so we don't confuse these, because these are the hypothalamic ones. I'll draw this line like this. There we go. All right. So let's do number one, gonadotropin releasing hormone. What is that stimulating the release of? It's going to stimulate the release of what we call the gonadotropins. And there's two gonadotropins. There is what's called luteinizing hormone and follicle stimulating hormone. Luteinizing hormone is sometimes written as LH, and follicle stimulating hormone is sometimes written as FSH. So these hormones are released by this tissue here in the anterior pituitary, and they will travel down, and where do they go to? They go to the gonads. So the gonadotropins go to the gonads. Now the question is, what are the gonads? The gonads are the testes and the ovaries. And what do these hormones do? Well, they're named after what they do in the female reproductive system, so what they do in the ovaries. Luteinizing hormone stimulates ovulation. Luteinizing hormone stimulates ovulation in the female. And follicle stimulating hormone stimulates follicle development. Follicle development. Now, if you think about, so I've done a number of videos about the female reproductive system. You've got the 28-day on average cycle where the oocyte, the egg, needs to develop. Now, in order for that egg to develop, it needs to be surrounded by cells that keep it happy and healthy and nourish it. Those cells are called follicle cells. So at the beginning of this cycle, you have follicle stimulating hormone being released to help the development of those follicle cells to look after the oocyte, which is one of the reasons why the first part of the female reproductive cycle, first half-ish, is called the follicular phase, right? Then, just before day 14-ish, luteinizing hormone is released, the egg ovulates and is released, and that's why this is called the luteal phase, right? In addition, these hormones, in doing this process, stimulates more hormones to be released, like estrogen and progesterone. So estrogen and progesterone are released off the back end of this. Now, what do they do in the testes? Luteinizing hormone in the testes stimulates testosterone to be released, and follicle stimulating hormone in the testes stimulates sperm production. All right. So that's the gonadotropins, stimulated by the release of gonadotropin releasing hormone. When growth hormone releasing hormone is released and travels down, here it's going to release growth hormone. So now we've got the release of growth hormone. Now, what does growth hormone do? Well, growth hormone, sometimes just written as GH, goes to pretty much every tissue of the body. There's receptors for growth hormone everywhere. And so growth hormone goes to nearly all tissues and stimulates growth and development. What type of growth? So protein synthesis, bone elongation, things like that. So that's an easy one. Then we've got corticotropin releasing hormone. Corticotropin releasing hormone. Let's write this one. No, we'll keep it down here. Corticotropin releasing hormone. Sorry, that's the one up there. Corticotropin releasing hormone travels down and stimulates the release of adrenocorticotropic hormone. Oh my gosh, that's a mouthful. Let's break it up so it makes sense. Adreno tells you the adrenal gland. Cortico tells you it's the cortex of the adrenal gland. Tropic tells you more hormones are going to be released. So it goes to the adrenal cortex to tell it to release more hormones. What is the adrenal cortex? This is the adrenal gland. So let's draw it up here. If I've got my kidney, and on top there's the hat of the kidney, which is the adrenal gland. So here's the adrenal gland. The adrenal gland can produce and release a number of hormones. One of those hormones is called cortisol. Another one of those hormones is called aldosterone. And another one of those hormones are called the androgens. And these are sets of hormones. Now, cortisol fits under an umbrella of hormones called the glucocorticoids. Glucocorticoids, and aldosterone sits under the umbrella of mineralocorticoids, and the androgens are the sex hormones. I've done a whole video on the sex hormones as well. Now, corticotropin releasing hormone, released, goes down the hypophyseal portal system, stimulates the tissue in the anterior pituitary to release adrenocorticotropic hormone, and then that goes over to the adrenal gland and stimulates the release of cortisol, aldosterone, and androgens. What do they do? Well, cortisol, known as a glucocorticoid, plays around with glucose levels. Corto is telling you it's at the cortex, and the oid tells you it's a steroid. So it's a steroid hormone that plays with blood glucose levels. In times of stress or fear, you release cortisol, and what it does is it mobilizes glucose into the bloodstream. So increases blood glucose. Why? So that we've got the energy available so that we can repair or utilize it after the stressful situation. Aldosterone, mineralocorticoid, because it's a steroid hormone produced by the cortex that plays around with an important mineral called sodium. And what it does is it increases sodium reabsorption. We draw up the nephron here. What this does is it helps us reabsorb sodium. So we throw now sodium back into the body. Throw sodium back into the body. Why is that important? Because remember, water being a hydrogen with two oxygens, the oxygen is slightly negative charged, the hydrogen is slightly positive charged. It loves charges, which means wherever sodium goes with its positive charge, it's going to pull water with it. So if I reabsorb sodium, I reabsorb water. And therefore, aldosterone gets released when we want to increase our blood volume. So we want this to get released when we want to increase our blood volume. That's the desire, okay? The increased blood glucose here is for help us regenerate, I suppose, is one way of putting it, after a stressful situation. Now, the androgen sex hormones don't stress because they're not a major releasing factor that happens here. These two are in response to adrenocorticotropic hormone. Number 4, thyrotropin. All right, so thyrotropin, this one's a relatively easy one. Number 4, thyrotropin releasing hormone goes down and releases what we call thyroid. It's got two names, thyrotropin, but more commonly it's called thyroid stimulating hormone. Thyroid stimulating hormone, often written as TSH, and that's important because when you look at blood levels of TSH, that can help you with hyper or hypothyroidism. What does this hormone do once it gets released by the anterior pituitary? It travels to the thyroid gland and tells the thyroid gland to produce thyroid hormone, which is T4 and T3. Now T4 is the one that's produced the most, but it actually converts to T3 at the tissues. Therefore T3 is the active one, triiodothyronine. And it's important because what does thyroid hormone do? It helps regulate metabolism, among other things. But yes, regulate metabolism. Which makes sense because if you increase the amount of thyroid hormone, you increase your metabolism. When you increase metabolism, you use energy, right? So you lose weight, you sweat. These are some of the side effects. If you don't have enough, you slow metabolism, which means you hold on to nutrients and you gain weight and you can feel cold because you're not generating the heat from metabolism. So that's what the thyroid stimulating hormone does here. Now the other two, somatostatin's easy. If we don't want to release growth hormone, we release somatostatin. It inhibits that growth hormone. Somatostatin gets released, says no more growth hormone, thank you very much. Prolactin is the fifth one that gets released. It's the only one that doesn't have a stimulatory factor. Prolactin is the only one that doesn't have a stimulatory factor. Prolactin. Prolactin again gets released by these cells in the anterior pituitary and it promotes, it's in the name, it promotes lactation, right? It's prolactation. So stimulates milk production. Not ejection, because that's oxytocin, but milk production, that's prolactin. Here's how it works. Prolactin will pretty much always get released, right? So prolactin will always get released to some level, but dopamine, right, is going to be released to inhibit it. So when we don't want to produce milk, dopamine is constantly inhibiting these cells of the anterior pituitary to say, no, prolactin, thank you very much. But once you get suckling at the nipple from an infant, this suckling inhibits the dopamine. So if you inhibit the dopamine, there's no dopamine being released here, and then the cells of the anterior pituitary are free to make as much prolactin as they like. So that is stimulated by suckling. Suckling is the positive regulator of that. All right. Right, that is an overview of the hypothalamus, its hormones, and the pituitary hormones as well. I hope that makes sense. I'm Dr. Mike. Hi everyone, Dr. Mike here. If you enjoyed this video, please hit like and subscribe. We've got hundreds of others just like this. If you want to contact us, please do so on social media. We are on Instagram, Twitter, and TikTok at Dr. Mike Todorovic, at DrMikeTodorovic. Speak to you soon.